This video is for lesson 5.2, part 2. So in this video, we're going to talk about functions. So first, let's define what a function is. A function is a relation that assigns exactly one value in the range, the y, to each value in the domain, the x. Remember that a relation is just a set of ordered pairs. So what this is saying is that basically, kind of in easier to understand terms, in order for a relation to be a function, you cannot have any repeating x values. So if you see your relation and you see two x values that are the same, then it is not a function. Let's look at a few examples. So to determine if a relation is a function, number one, look at the list of ordered pairs and determine if there is more than one of the same x value. If there is, then it is not a function. If every x value is different, then it is a function. The second option is to use the vertical line test, which I will show you how to do in a minute. So let's look at these three sets of ordered pairs. These are three relations. Which one of these shows a function? Or which of these show a function? There can be more than one. So the first one is a function because all of the x values are different, 0, 1, 2, and 3. It does not matter that we have two of the same y values. That's okay. What we can't have is two of the same x values. For the second set, this is also a function because we have the same situation. All four x values are different. And our third example is not a function, and that's because we have two x values that are both positive 2. If we're using a graph, we can use the vertical line test. So if the graph passes the vertical line test, then it is a function. If the graph fails the vertical line test, then it is not a function. So here's how you apply the vertical line test. Plot your points, and then you want to consider the fact that you do not want the 2 points to be in the same vertical line at any one point. So if you just think about where these points are on the graph, at any point do you see 2 points that share the same vertical line? And then we see right here, these 2 points are on the same vertical line. So what this means is this fails the vertical line test, so it is not a function. And basically this is because both of these points have the same x value. So this is 2, 0, and this one is 2, 3. They both have the same x value of 2. So that's another reason why this fails the vertical line test. It is not a function. Let's look at some other graphs and see if we can determine whether or not they are a function. This graph is a function because it passes the vertical line test. This graph is also a function because it passes the vertical line test. This graph is not a function because it fails the vertical line test multiple times actually. But just to show you, here is a vertical line. It hits the graph twice, which means it is not a function. This graph is a function. It passes the vertical line test. The circle fails the vertical line test, so it is not a function. And for our final example, this is a tricky one. This actually does pass the vertical line test, even though it looks like there are 2 points on the same vertical line. Since this one is an open circle, this is actually not included as a value, whereas down here this is a closed circle. So we call this a function because of the open circle over top of the closed circle. So this is a function. Okay, we can take any function and write an equation that describes the function. So here's a few examples of what we call a function rule might look like. And throughout this chapter, we'll be exploring all sorts of different function rules and different types of functions, but for now, just to show you an example. A function rule is just an equation with two different variables. A function rule can also be written in what's called function notation. And basically, function notation is when you replace this, f of x is how you read it, with the y in an equation. So for example, we can take a simple equation like y equals 3x plus 4, and we can put it into function notation by writing f of x equals 3x plus 4. Really, they mean the same thing. Both the y and the f of x represent the y values or the range values. So it doesn't change what the equation is representing at all. Okay, and for our last example, this question says find the range of the function f of x equals negative x squared for the domain -1, 0, and 1. So what I'm going to do is I'm going to evaluate f of -1. So what I'm going to do is I'm going to replace the x with a -1 in the equation that we were given. So I'm going to put the -1 here and the -1 here, and both in parentheses. So this becomes -1 squared is 1, and then bring down the -1, that's -1. The next one is 0. F of 0 equals 0 squared is 0, and then -0 is just 0. And then for our last one, f of 1, making sure we don't put the negative sign in the parentheses here, just to make sure we clarify this negative sign is part of the function. So that stays there. We're replacing just the x with a 1. So the negative sign does not go in parentheses. So here we have 1 squared is 1. Bring down the negative, we have -1 again. And the range are all of our y values. So these are our 3 y values. Since there are 2 that are the same, we don't repeat them. We just list the 2 in order from least to greatest. So our range are -1 and 0.